Okay, so let's go ahead and work on the warm-up. Which equation represents the relationship between the x values and the y values in the table? So what we're gonna do, we're gonna go ahead and find the change in x and the change in y. So from 0 to 2 is plus 2. From 2 to 4 is plus 2. From 4 to 16 is plus 12. From 16 to 28 is plus 12. So we're going to go ahead and find the rate of change, which is change in y over change in x. So that's going to be 12 over 2. And when you simplify it, it's 6. So this is also your coefficient. So it's rate of change. So it'll be 6x. Now, if you look at the x here, if you have a value of 0 on x, then the value of y would be your initial amount. So that means that's where it starts, so or crosses the y-axis, which is the y-intercept. So this would be y equals 6x plus 4, which is letter D. Another way you could do this is actually check to see if you replace x, what would it be? So y is equal 6 times, let's do the third one, 4. And always do the third one because that would give you a better chance that it's correct. So 6 times 4, that's 24, plus 4, that gives you 28. So in this case, that's correct. So that means I have this correct. Now let's look at number 2. Number 2, remember all the angles in a triangle equal to 180 degrees. So you write the equation as 40 plus 3x plus x plus 8. And all of that should equal 180 degrees. So what we're going to do now is we're going to combine like terms. So 3x and x, so that's going to be 4x plus my other like terms is 40 and 8, so that's 48. And all of this should equal 180 degrees. So now what we're going to do, we're going to go ahead and solve for x because we already know what's the equation. So we're going to go ahead and solve for x. So that's going to be subtract 48 because you're undoing the addition. So now we're left with 4x because 48 minus 48 is 0 pairs. Then 180 minus 48 is 132. We divide that by 4. So 4 divided by 4 is x, and 132 divided by 4 will give us 3, remainder 1, bring down the 2, another 3, remainder 0. So x is equal to 33, and that would be letter C. So let's look at what we've been doing before the spring break. We were doing probability, and all we were doing is checking to see what would be the favorable outcome over the total outcome. So in here we have 1, 2, 3 red tiles, 1, 2, 3, 4 blue tiles, 1, 2, 3 yellow tiles, and 1, 2 green tiles. So now if I add them all up, this is going to equal to 12 tiles. So the probability of it being a yellow tile, when you actually pick randomly, so a yellow tile would be 3 out of 12. Here they're asking for the probability of blue, so that means there's going to be 4 blue out of 12, which is the same as 1 out of 3. So the probability of picking a blue tile is 1 out of 3. Now that's a theoretical probability, and that's what we have been doing before the spring break. But we're going to add today's experimental probability. And experimental is basically the same thing what you're doing. You're actually experiencing the event. You're actually doing it. So what we're going to do, we're going to go ahead and put all these tiles in the cup. And I'm actually doing it physically. You won't be able to see it, but I'll be doing it physically. I'm going to be picking it and then picking a tile and telling you what that is. So the first one would be yellow. So that means I picked yellow on the first one. I'm putting it back in and mixing it up, picking another one. That's blue, so that's 1. I'm gonna do 10 tries. I'm gonna go to the next one. I pick red. I'm gonna go to the next one. I pick blue again. Keep going. Yellow. Red. Green. 3 more to go. Yellow. Yellow. 1 more, and that would be blue. Okay, so now that we have that, I know that I went ahead and did 10 trials. So I know red was picked twice, blue was picked 3 times, yellow 4 times, and green 1 time. So when I add them all up, that's going to be 10. So if I want the probability of blue, then that's going to be 3 out of 10. So when you're doing experimental probability, you're either going to get a table. It's either going to say that they already spin the spinner, they already flipped the coin, they already tossed the cube. They're going to say that an activity has happened and this is the results. So when you're looking for experimental, that's what you're looking for, and you're still doing it the same favorable outcome over the total trials or the total experience. So let's go ahead and get our foldable ready to take notes. So on your foldable, you have a whole page. What I need you to do is go ahead and fold it the long way. You're going to trace the lines that you see through the foldable, and you're going to write theoretical probability, experimental probability for the second part, comparing theoretical probability and experimental probability for the third part, and the last part will be making predictions using probability. Now, making predictions we're going to leave for tomorrow, so make sure you keep your foldable, and I'll go ahead and put up that information tomorrow on Google Classroom. Okay, so let's go ahead and start with the notes. So the first part is theoretical probability, and theoretical probability is just a number of favorable outcomes to the number of total outcomes. So we're looking at a bag, it has marbles, and it's asking for the probability of striped marbles. So that's going to be, there's 3 striped marbles, 1, 2, 3, out of 4, 5, 6 total marbles. So when you simplify it, 3 out of 6, you're going to divide by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. So that means the probability of getting a striped marble, it's half the chance. So that's an even chance. That's an even chance that's equally possible. Or equally likely, that's what it means. So when you have half, that means it's equally likely or even chances. Okay, the second part is the experimental probability. Remember, this is something that has been done. If you look, the word drawn means that they actually did it. So that's going to be your keyword. So the experimental is the number of favorable outcomes to the number of trials performed in the experiment. So whenever they give you a table, they tell you how many trials, and that means they've done the experiment already. So again, they're asking for the probability of striped marbles. So this is going to be, there's 20 striped marbles out of how many trials? Well, if you add this up, 2 plus 8 is 10, plus 20 is 30. So that's going to be 20 out of 30. Well, 20 out of 30, you divide by 10. That's going to give you 2 out of 3. So the probability, the experimental probability of getting a striped marble, that's going to be 2 out of 3. So now we already determined the probability of theoretical and then the experimental. And then we're going to compare the probability by using the words greater than, less than, or equal to. So remember, greater than is going to be going to, pointing to the right. Less than is going to be pointing to the left. And equal to, well, obviously it's going to be the equal sign. So when we were doing theoretical probability on our marbles, bags of marbles, we knew that it was going to be half. The probability of experimental would be 2/3. So what we're going to do, we're going to compare half is compared to 2/3. Now, some of us will be able to do it this way, but for the most part, I'd rather you find a common denominator. So the common denominator between 2 and 3 would be 6. So what I'm going to do, I know 2 times 3 will give me 6. So 1 times 3 will give me 3. 3 times 2 will give me 6. So 2 times 2 will give me 4. So now that I have that, I could compare it. So is 3, 6 greater than or less than 4, 6? So in this case, 3 is less than 4. So that means this is less than. So we're going to go ahead and write it out in words. So the theoretical probability is less than experimental probability. Oops, I spelled that. So that's your statement. Make sure that you understand that that's what you're looking for, less than or greater than. I went ahead and put the symbols for you so you could be able to remember what they represent. So now here's your practice. Make sure that you are reading through all the notes. Remember, we are looking for experimental probability, which is what you've already done. Then you're also looking for theoretical probability, and it's just based on what the spinner has or the bag has or anything like that. And the only thing that I want you to correct is if you look at number 9, number 9 should have theoretical instead of experimental. So make sure if you print it out from our website or from the Google Classroom that you see that that we did change it. More than likely, I'm going to go ahead and try to change it. If I don't get to it, then just make sure that number 9 should say theoretical probability. So good luck on that. If you need to go back and watch the video again, make sure you do so. Make sure you're working on this and make sure you turn it in as soon as you're done.